Okay, for this video, I'm going to discuss centroids and center of gravity of a three-dimensional body or centroid of a volume. The center of gravity G of a three-dimensional body is obtained by dividing the body into small elements and by then expressing that the weight W of the body acting at G is equivalent to the system of distributed forces delta W representing the weights of the small elements like this one. Okay? So the whole body, total weight niya naka-concentrate sa center of gravity. And then individual elements delta W1, delta W2, and so on. Okay. Oh. Denoting by R bar the position vector of G. For the centroid, R bar. Basta na ay bar centroid. We write that W is equal to the sum of the elemental weights delta W, this one. Sa mention of force, kini weight lang equal na sa sum of the individual elements, elemental weights. Okay, so we write that W is equal to the sum of the elemental weights delta W and that its moment about the origin O is equal to the sum of the moments about O of the elemental weights. So in vector form, moment is R cross F ba? So ang moment daw ani weight equal about point O is equal to the sum of the moments of all in elemental weights. This one. R cross F, summation sa R cross F. Okay. From the last equation, this one, we can observe that the weight W of the body is equivalent to the system of the elemental weights delta W if the following conditions are satisfied. This one. Kaya daw, W equal daw na siya sa sum of the elemental weights. The weight W of the body is equivalent to the system of the elemental weights delta W. This one. And ang moment sa, okay, ang kina moment, R bar cross delta W is equal to equivalent sa sum ani. This one. Okay. And again, if we increase the number of elements, the result is mo decrease ang size sa element. We obtain in the limit W is equal to the integral of dW and R bar W equal to the integral of R dW. Resolving the vectors R bar and R, this one, into rectangular components. We all know sa forces in space na ang coordinate sa R are xi plus yj plus zkx yz. Therefore, for R bar, x bar, y bar, and z bar also. So, if we resolve these vectors, R bar and R into regular components, we note that the second of the relations, this one, is equivalent to the three scalar equations. Okay, x bar, so sa R sa natay x, and then y bar, and then z bar. Okay, ato lang gi-resolve ang R bar and R into rectangular components. X bar, y bar, z bar, and then x, y, and then z. If the body is made of a homogeneous material of specific weight gamma, the magnitude dW of the weight of an infinitesimal element can be expressed in terms of the volume dV of the element. And the magnitude W of the total weight can be expressed in terms of the total volume. Same sa area, weight is equal to gamma times volume. This one. So from the expression sa dW, we replace it with dV. So this one, we replace W by this one, gamma V, and dW gamma dV. So gamma V and then gamma dV, ang gamma will be cancelled. Gamma V tapos gamma dV, makancel ang gamma. So ang result is x bar V equal to integral of x dV. Same will happen sa y bar and z bar. So this is y bar V equal to integral of y dV and then z component and z bar V equal to integral of z dV. Mao niya, this will be the formula that will be used sa pag-determine o pag-locate sa centroid sa volume. Especially if the solid is a solid of revolution. We use integration. So mao niya formula. Anyway, this was discussed sa integral calculus, and if you want to see if you want to know this method of integration, you can watch my videos sa YouTube channel na ako. So the point whose coordinates are x bar, y bar, z bar is also known as the centroid C of the volume V of the body. The centroids of several common volumes are shown below. Hemisphere. That's the hemisphere. And x bar is 3/8 of A. X bar. And then the volume is 2/3 pi A cubed. Semi-ellipsoid of revolution. Bale, you have a semi-ellipse and then revolves about the x-axis. Money ang result. Semi-ellipsoid of revolution. And x bar is 3/8 of h. And the volume is 2/3 pi A squared h. Next, paraboloid of revolution. A semi-parabolic area revolved about the x-axis. One result, the x bar is h/3 and the volume is 1/2 pi A squared h. And then we have the cone. You also have x bar and volume, and then the pyramid. Okay. So you can make this one as your guide every time mag-solve mo problem. It should be observed that in general, the centroid of a volume of revolution does not coincide with the centroid of its cross-section. For example, kining hemisphere, ang cross-section niya is a semicircle. We all know nga for a semicircle, ang centroid niya is 4r/3 pi. Therefore, dili same ang location sa centroid sa semicircle o ang centroid sa hemisphere. Okay. Same with this one, cone. Ang centroid sa cone is 1/4 sa h. Pero ang cross-section niya, which is a triangle, ang centroid niya is 1/3 sa h. So wala nag-coincide. So this is correct, no? that the centroid of a volume of revolution does not coincide with the centroid of its cross-section. Okay, so this will be our main topic, composite bodies. If a body can be divided into several of the common shapes previously shown, its center of gravity G can be determined by expressing that the moment about O of its total weight is equal to the sum of the moments about O of the weights of the various component parts. This is similar to area. We start with weight, the center of gravity, and then after this, if the body is a homogeneous material, its center of gravity coincides with the centroid of its volume. Okay? And we obtain this one. Homogeneous na, same ang material. So, we can replace W by gamma V. Gamma V, gamma will be cancelled. So, instead na weight, volume. So, mausad ni atong formula gamiton in analyzing composite bodies. Okay. So, this is similar to area, but this time volume. Volume. So, one problem. Determine the location of the center of gravity of the homogeneous body of revolution shown, which was obtained by joining a hemisphere and a cylinder and carving out a cone. So, hollow part niya up to the origin. So, pag sa divide mo so, okay. Because of symmetry, the center of gravity lies on the x-axis. Bali, symmetrical siya sa z, symmetrical siya sa y. So, our y bar is 0, z bar is 0. By inspection, by inspection, symmetrical siya sa y o z, sa x dili. So, therefore, we will only solve for x bar. Okay. So, as shown in the figure below, the body can be obtained by adding a hemisphere, this one. Gikatan siya dire. Hemisphere, i-add na to ang cylinder. And then i-subtract ang cone. Kay hollow part mo. Okay. So, construct ang table x bar ta, x lang ta, x distance. Kaya nga itong y bar 0, z bar 0 also. So, element 1, the volume of a hemisphere is 2/3 pi radius cube. So, it's 2/3 pi, the radius is 60. This one. For element 2, cylinder, the volume of cylinder is area of circle times height. So it's pi r squared times, this one is 100. Pi r squared height, this one. And then element 3 minus the volume of a cone is 1/3 pi r squared h. So 1/3 pi, the radius is 60, again 60. And then height of 100. This is minus. Typo error, minus. Negative 120,000 pi. So, to compute for the total volume, that's 144,000 pi plus 360,000 pi minus 120,000 pi. The result is this. 384,000 pi. Now, sa x distance, 3/8 of 60 is 22.5. But then it is located on the negative x-axis. So negative 22.5. For the cylinder, the height is 100. So nasa center ang center of gravity, not geometric center. So 50. And then centroid sa cone is, if a reference sa base is 1/4, 1/4 sa h, okay? 1/4 sa h. So therefore, with respect aning vertex, it's 3/4 na. With respect sa base, 1/4, there is 3/4. So 3/4 of 100 is 75. After this, multiply x times v. You'll notice na negative, negative 120,000 pi times 75. You have this one. You add, and then you solve for x bar. Our x bar is 15 millimeters. Our y bar is 0 and z bar equal to 0. Another one. Use the method of composite volumes to determine the location of the centroid of the volume for the machine part shown in the figure. This one. Okay. We note that x bar. Okay. Take note sa orientation, no? Sa labeling sa axis x, y, and z. So, by inspection, symmetrical siya sa x-axis. On the volume on this side, the positive x and negative x, same lang. Therefore, ang x bar na to 0. Because the YZ plane is a plane of symmetry of the volume. So we will only solve for y bar and z bar. So to calculate y bar and z bar, the machine part can be considered to be composed of the 4 volumes shown in the figure below. So bali kini is actually a rectangular solid, this one, this rectangular solid, kana plus semi-cylinder, this one. Semicircle times thickness man semi-cylinder. By the way, 3.25 because kinina 4 is based na there is a bottom. Pero ang atong XY plane kinaaman there, so we have to subtract 0.75. So it's 4 minus 0.75. So kinina distance is only 3.25. Okay. Plus rectangular solid, this one. Minus cylinder, kini. Minus this one. Okay, so we have 4 elements. Okay, this is our table. Okay. Volume 1. The volume of a rectangular parallelepiped is length times width times height. So it's 5 times 3.25 times 0.8. 13. 2. Ang volume sa semi-cylinder is area of a semicircle times thickness na 0.8. This one. Area of semicircle times 0.8. Bali, volume na to is area times thickness. Element 3, area 4.3 times 5 times thickness 0.75. And then minus cylinder area of a circle times thickness. Minus area of circle pi r squared times thickness. I-add na tanan and mo ni ang volume. Total volume 33.052. Okay. For y, okay, let's start with this. Take note, ha? Y, this is y-axis. So, ang centroid ang y value sa centroid sa element 1 is sa negative na y-axis. Okay, the thickness is 0.8, so nasa sa middle, which is negative 0.4. Okay, 0.8 man ang thickness, so nasa tunga 0.4. Pero negative, kay negative y-axis. For element 2, same lang, negative 0.4 also. Okay, 1/2 sa thickness na. Okay. For element 3, nadiri ang centroid niya. Okay, so actually, 1/2, no? 1/2 sa 4.3, which is 2.15. Pero naman tayo distance na 0.8. So, i-subtract na to. 1/2 sa 4.3 minus 0.8. That's the answer. Nara. It's 4.3 over 2 minus 0.8. And it's 1.35. For element 4, okay, ang y niya is negative 0.4 also. Okay. Same lang man silang tulo. Ang ilang centroid is nasa negative na y. Negative 0.4. Ang sa z is this one. For element 1, it's actually 1/2 sa 3.25. It's 1.625. And then, for element 2, ang iyang z bar is 1. Centroid sa semicircle, that's 4r over 3 pi plus 3.5. Okay, semicircle yung cross-section, ang yung centroid is na dere. 4r over 3 pi, which is the centroid of a semicircle. 4r over 3 pi plus 3.25. It's 4.311. For element 3, ang z niya is nasa bottom, below the xy plane. Below. And since ang thickness is 0.75, so 1/2 siya. It's negative 0.375. While ang sa element 4, nadiri ang centroid, so it's 3.25. After this, multiply lang. Y times V, Z times V. Y times V lang. Y times V, Y times V, and so on. And then Z times V. Okay. After this, i-add summation of YV. Then you add summation of z times v. So we can now locate or determine the value of y bar and z bar. So x bar equal to 0, axis of symmetry. Y bar, this one, and then z bar. Okay. So that's it. Again, the most important part here is this one. In solving centroids or locating centroids, sa distances ang difficult na part. Make sure na dili sobra, dili kulang ang values nimo. And katong table nga gipakita ganina, make it as your guide now para sa distances. And once correct imong distances, then 99.9% correct ang centroidal distances. So thank you for watching. I hope that you have learned something from this presentation. God bless.